Professor Hildebrandt here. This is going to be an overview of Chapter 3 for Econ 3402 at the University of West Georgia. I have two other videos where I'm working more examples and going into more detail, so I'm going to just do kind of a more top-head overview, work one of the examples from the textbook, but then if you need more on some of these measurements, then you'll need to watch those other two videos as well. So in Chapter 3, we're going to focus on how we describe data, and specifically in this chapter, we're going to learn how to calculate what we call measures of location and measures of dispersion. And so there's kind of two divides here in the chapter. So in terms of location, we're talking about finding the center of the data. Typically, you guys are familiar with the concept of an average, right? An average grade, an average batting average, right? There's lots of averages out there. Dispersion, though, is the variation or the spread in our data set. And so, sometimes we need both pieces to get a clearer picture of what our data is telling us. Let me just give you an example really quickly. So maybe we took executive salaries for some internet companies, and we found that they ranged from, 70 to 90,000. Okay. And we're also told, though, that the average is 80. So that's what the average person makes. And then we compare that to these pharmaceutical companies over here and their executives. And we're also told that the average salary for the pharmaceutical executives is 80,000. And so if we were just looking at the averages, we might think they're the same, right? The executive salaries for these two different industries are identical. But what if I then told you that the range or variation on this side, the minimum was 40, which is a good bit lower than 70, and then on the upper end, 120, which is a good bit higher than 90. So there's a lot more variation or spread over here in this range, even though the two averages are identical. So hopefully that gives you a little bit of an idea of what we're going to be talking about here in Chapter 3. So the first part of the chapter is measures of location, and we have three common measures: mean, median, and mode. These are, I feel like they're very intuitive. They're things you guys should already know. And again, I have another video where I go through this more closely. But basically, your mean is the average. The median is the value in the middle, and then the mode is the value in the data set that occurs most often, okay? You do need to know these. This is the formula. So here's your first formula in Chapter 3 for finding the population mean. We pronounce that mu. It's the Greek lowercase letter mu. N is the number of values in our population. X is any particular value, and then the Greek capital letter sigma indicates the mathematical operation of addition. And so sigma X is the sum of all values in the population. Y'all, it's simple. You add all your values up, you divide by the total number of values in the population. That's how you get an average. That's the most I'm going to say about it in this video. Watch the other one if you want more examples. All right, so I'm going to skip this. A sample mean is really just the same thing. We do have our textbook here, gives us a different definition, and I'm going to pause for a moment because I just want you to understand when you see this term that we call X bar, it's just an X with a bar on top, okay? It's indicating specifically a sample mean, and remember from Chapter 1, a sample is a segment of our population. And so that's the only difference between this and a population mean. I just wanted you to see that the lettering here is different, but we calculate it the same way. And there's an example. Again, median is the midpoint. So you would first rank your values from minimum to maximum, and then the median is the value in the middle. Okay. You might have to calculate the average of the two middle values. So if your data set has an even number of observations, then there wouldn't be a median without doing this right here. Again, calculating the average of your two middle values. And so this was an example. We had 10 observations, 10 adults, and the number of hours they were on Facebook last month. And so we arrange it in order. When you do this, if you look here, the middle two values are right there, right? Because there's 4 on this side and 4 on the right-hand side. And so we would say that the median of the data set is 6, even though that value was not one of our observed observations. Okay. I'm not going to say that. Mode is just the observation that's occurring the most frequently. And so we can find mode for our nominal level data. Note, though, that a data set can have more than one mode. Okay. So just looking at some differences here. So this first graph, number 1 here, we would say is a symmetric distribution. Our mean, median, and mode are all the same at the age of 30. Whereas graph number 2, we would say is positively skewed distribution. And so you can see that our mean for weekly income is down here at 60, and then the median and mode are less than the average. And then here in graph 3, we have a negatively skewed where the mean is on this end, and then your median and mode are greater than the average. All right, so this is not in my other video, so I'll take a moment to talk about a weighted mean. And this is just found by multiplying each observation in our data set by what we call a corresponding weight. And so this example here is talking about a construction company, and it pays its hourly employees either $16.50, $19, or $25 per hour. And then it tells us the breakdown. We have 26 total hourly employees, 14 are paid at the lowest rate, 10 are paid at the 19 rate, and only 2 are paid at the highest rate. And so instead of having to list out individually all 26 wages that those individuals earn, we can kind of group them in categories based on, again, what we're calling that weight, which is here is their hourly wage. And so we take the 14, we multiply times 16.50, 19 and 10, here you go. Down here, 14, 10, and 2, that's the number in each grouping, right? But that gets us to the 26 total employees that we're looking at. And so the weighted mean or weighted average for this group of data is $18.12. Geometric mean is, I'm trying to decide if I really want to get into this right now. You know what? We're not going to get into this one. So if I mess up, I'm going to put a question on your Connects assignment that talks about geometric mean. Somebody do me a favor and text me or email me, okay? We got to keep going with material here. So we're skipping geometric mean. Decision made. All right, so the second half of the chapter talks about dispersion, or again, the variation or spread in our data set. And so you've probably heard of this basic one here, a range. It's just taking your maximum and subtracting out your minimum value. But there's a really big weakness in this measurement of range because it only uses 2 values in our data set, okay? So it can be extremely influenced or greatly influenced by extreme values, but it is easy to compute and understand. Instead, we're going to focus more on this next guy, population variance. And so here is another formula that you're going to need to keep up with. And so here we have the lowercase Greek letter sigma, and the population variance then is read as sigma squared. So you kind of make this little thing, and you put a squared, and there you go, sigma squared. Again, X is the value of a particular observation in our population. Mu, remember from earlier in the chapter, that's our mean of the population. And then N is the total number of observations in the population that we're looking at. And so the difference here, and why this is a better study of dispersion, is because variance is considering all the observations in our calculation. The units are somewhat clunky to work with, though, because, you know, if we were talking about dollar values, once we square it all, it becomes dollar squared. What does that mean? What does a dollar squared mean? And so that can be a little bit problematic. Similarly, for a sample within the population, we have another formula here for sample variance. Okay, so this one here, and again, it's really similar, but we're using now the letter S. So S squared represents sample variance, and the one difference is we are taking the number of observations in the sample, but then we subtract a 1 from that. And there is a reason for it, a mathematical reason, and it's really complicated. And I'm just not going to go into it. You just need to remember this formula, okay? Trust me, we will all be better off if we just do it that way. So let's work through this example again, going from, we're going to have 5 part-time employees at Home Depot, and their wages are $12, $20, $16, $18, and $19 an hour. And by the way, I have another video on variance, where I'm just talking about variance and standard deviation. And if this is still confusing after you watch this video, watch the follow-up, because I'm working yet another example. Okay, I'm trying to give y'all as many examples as possible since we're doing so much online. So if we calculate the mean, we would get a sample mean here of 17. And so then the question asks us to calculate the sample variance, okay? And so again, we are using that equation that S squared equals the sum of all of our values minus the sample mean, and then squared, divided by n, our total number of observations, minus 1. And you guys, I recommend when we're working these by hand and not in Excel, that you make yourself some columns like this. So in column number 1, I would write down my 5 wages. In column 2, I would label it X minus X bar, so I can find all those values first. Then in column 3, I take the values from column 2 and I simply square them. So once I do that, sorry y'all, let me go back. Once I do that, I sum all of them up and I get to a value of 40, which I then plug into my equation, put my 5 minus 1 in the denominator, and my sample variance is $10 squared, which again doesn't make any sense to most of us, probably any of us. But I watched students in the spring try to just jump straight to this formula all at one time, and it's big and it's messy, and you're more likely to make a slight error that's going to mess up your answer, okay? So even when you're working in Connect on your assignments, I would do this method. I would have the columns and work through it that way. The last part of the chapter then gives us this new formula for standard deviation. And we're just taking the square root of variance. So instead of S squared, now it's S. So S is the sample deviation. Standard deviation for the sample. And the equation underneath the square root bar is just the equation for variance. So now we're going to get back to the original units, right? We had $10, or 10 in squared dollars, and then we take the square root of that, we get back to just a unit of dollars. So some characteristics about standard deviation here. Again, we get back to the same units as the original data set. That's very important. The square root of the average square distance from the mean. So that's what it's showing us, is on average, how far are we from the mean of our data set. It cannot be negative, and it is the most widely used measure of dispersion. So hold on, I thought I had another slide here. But if we go back to our example earlier with the wages, we found that the sample variance was 10 in dollars squared, right? And so then our standard deviation is simply the square root of 10, which is $3.16. And so again, that's showing us the distance from the mean is on average $3.16, okay, for our data set. Okay. This theorem, we're going to get to this in a later chapter, so I'm going to skip this for now just to keep us going. And the empirical rule as well. What we're eventually going to find is that some of our data is symmetrical, and we call it a bell-shaped frequency. And so we have 68% of the observations are within plus and minus 1 standard deviation of the mean, 95% are within plus or minus 2, and almost everything in a symmetrical distribution is within 3 standard deviations from the mean. So the mean would be here in the middle, right? And then we were moving out 1 standard deviation is here, plus or minus 2, and then 3. But again, we're going to go into this in more detail in a later chapter, so I'm going to save it for that. Okay, that's all I have for this one. And again, there's 2 more videos, so make sure you guys take a look at those.